Welcome to this episode of the Bentley Going Digital in Energy series, where I'll be joined by Gavin England, Senior Product Marketing Manager at Bentley, to talk about how energy infrastructure design, construction, and operations depend on understanding what's above, on, and below the ground. Now, energy assets are complex by nature, and they don't exist in isolation. Every energy asset has a critical relationship with its natural environment, both above, on, and below ground. So, understanding that full environmental context is essential in designing, constructing, and operating them effectively. We'll also look at how combining digital asset data with geospatial and geological information helps improve design accuracy, reduce construction risks, and minimize ecological disruption. Now, we'll also discuss how AI is helping teams create 3D models from photos and automatically detect objects and defects within geospatial and reality capture data, making it easier to bring everything together digitally. And we'll explore how infrastructure digital twins and the digital thread connect all this info, the above, on, and below ground environments, into a single, visual, easy to access environment that supports better, faster decision making right across the entire asset lifecycle. So here's my chat with Gavin. Gavin, what do you mean when you talk about designing energy assets in the context of geospatial data, be that on ground or the subsurface environment?
Yeah, well, as we all know, as we're all aware, energy infrastructure is, by its very nature, incredibly complex. Think of an oil or gas platform or a power generation plant, nuclear, for example. So they require intensive engineering effort to develop, to construct and operate. Even solar and wind farms, especially offshore, they bring a high level of complexity too. Now, that complexity increases when you consider that these assets, they're not designed, built or operated in isolation. Every energy asset has a critical relationship with its natural environment. So the land that it's sited on, for example, that plays a crucial role. The terrain, the elevation, the vegetation in the area, natural geographical features, existing buildings and utilities as well. And also the geology underneath the ground. All of this dictates how the infrastructure has to be designed and constructed, and actually to a certain extent operated. So understanding this natural environment as well as the asset itself is vitally important. So an organisation must take all of this into account when they consider not only the design, but also the construction and operations of the energy asset. Now, this obviously adds further complexity to the overall picture of the infrastructure, but it's an absolutely essential piece of this very intricate jigsaw puzzle.
Now, when you speak about that jigsaw puzzle, again, I suppose to harp in on the business context for doing this and the reasons. Why is it important to be able to design energy infrastructure in that context?
Well, as I mentioned, how you design, construct, and operate energy infrastructure is hugely dictated by its environment. So, for example, if you're constructing, let's say, a solar farm, a solar plant, the exact position of each solar panel is absolutely critical in order to maximize its energy output. And how you achieve that is completely dependent on the terrain that it sits upon. Similarly, if we think about wind farms, understanding location and landscape, they're important to ensure maximum efficiency, but at the same time, considering the soil and rock conditions below ground, well, that's also crucial to foundation design and construction to ensure a safe, resilient asset. For a geothermal plant, subsurface knowledge is even more important to make sure it's sited, constructed, and operated effectively. So without that high level of visibility of the natural environment, there are potentially huge risks, such as potential project delays, costly construction errors, environmental and ecological issues, and ultimately delivery of less resilient assets.
What benefit is there in bringing all of these elements together digitally?
So, Kevin, traditionally, understanding this natural environment that I've been talking about really involves manual data gathering. So things like on-site surveys, for example. And obviously this is important, but it's time consuming. And the data that's obtained from activities like these surveys, that data tends to sit in very isolated silos and is really only understandable by typically a small group of specialists. And that tends to disjoint processes. However, it is possible with the right technology digitally to bring these elements together very early in a project in an easy to access, simple to understand form. So the on-ground environment via geospatial data, the below ground conditions using visual subsurface simulation, and information about existing assets, often using reality data. So it's about bringing all of that together digitally. And I think the latest technology, new technology, makes a lot of this much easier now. So we've had geospatial data for many decades, but technology such as geospatial 3D tiles allows us now to stream and render these real world views in a much faster, much more dynamic way. We have technologies such as Gaussian splatting, which is a new, relatively new technology that provides us with a very fast, efficient way of navigating photorealistic reality capture data. And this gives us a much more true to life view of an energy asset. And of course, AI is playing its part too. So for example, we can now use AI to, well, do lots of things, but for example, creating 3D models from photographs that we can add into this holistic digital picture. We can use AI to automatically detect certain objects within that geospatial data, as well as automatically detecting defects in existing assets, again, using that reality data of the asset. So this holistic view that we get is really it's so valuable for many stakeholders. So for example, design teams, they can plan new assets working within an accurate model of the site, including landscape, terrain, and the subsurface, considering things such as underground reservoirs and soil conditions. So doing this even before any site surveys have taken place. So this ultimately all leads to better design accuracy, fewer issues during construction, faster project delivery, but it also helps to minimize ecological disruption because of that better understanding of the natural environment.
And where do digital twins come into play in all this?
I'm glad you asked me that, because an infrastructure digital twin, as we all know, that brings together all data related to an energy asset in a single accessible visual environment. So it allows all stakeholders in the organization and beyond to understand all aspects of an asset. Now, a truly open infrastructure digital twin, that's really important because that includes not just asset data, design data, whatever it might be, related to the asset itself, but all of that on and below ground information that I've just been talking about, such as that geospatial data. That's all within the digital twin. So it enables that holistic view in a very visual way, giving everyone knowledge of the asset, whether it's existing or in development, but doing so in the context of its natural environment and other things such as existing utilities or infrastructure, all centrally within that infrastructure digital twin. Now, the very visual, very accessible nature of a digital twin makes this very easy to achieve for everyone, anywhere, without the need for them to be able to use potentially complex specialist software products. Now, what the digital twin is doing is essentially creating a digital thread through the above, on and below ground information. So connecting it and ultimately allowing fully informed decision making. And what this does, it helps to reduce risk due to design errors, construction issues, operational problems. It decreases timescales and costs of engineering and construction. Essentially, the digital twins, bringing a digital twin and that digital thread into the equation allows teams to much more easily and more effectively make sense out of all of this complexity. It provides owners and engineering firms with a much clearer understanding of the project, leading really to on-time delivery of a very resilient, efficient asset.
Now, to make this a bit more real, can you share any examples of what folks have been doing with this?
Yeah, sure, Kevin. So there are a couple of examples that spring to mind. So starting with solar power. So a Chinese engineering organization called Power China Hubei, they needed to install about 15,000 solar panels in undulating terrain dominated by hills, forests and ponds. So it was a very complex situation. And of course, each individual panel needed to be sited specifically to optimize their efficiency, considering the terrain at the location of each panel. So using a digital twin containing geospatial data representing the exact landscape of the area, along obviously with the asset design data, so creating that digital thread between them, they delivered an innovative project which really maximized the production of the solar plant. That better understanding of the natural environment as they were developing the plant through that visual digital twin really helped to improve communication, reduce costs, and actually they were able to bring forward project delivery by about 30 days. The second example that I'm thinking of, actually also in China, is from Fujian Yongfu Power Engineering. So they had to design an offshore wind farm in, again, very challenging conditions. So it was a site that was frequently battered by typhoons, at risk of earthquakes, and with a very complicated geological environment. So they adopted a new approach to wind turbine design due to this unique, harsh scenario. But that meant, obviously, that they had to get it just right, particularly the foundations. So what they did is they brought together the above ground design of each wind turbine, as well as the subsea conditions and the below ground foundation design and that subsurface environment those foundations sit in. They brought all of that information together digitally so they could assess all of these aspects in one place. So designing each turbine and its foundations directly in the context of those extreme sea conditions and underground geology. So they could immediately understand the interaction of the soil with the wind turbine structure and the waves and the wind as the design was it being iterated as it was maturing. So they were able to optimize the strength of their wind turbines for those unique conditions. And at the same time, they also reduced costs by about 30%.
So, Gavin, for anyone that has been watching this, where can they go to find out more information?
Well, there's a whole host of additional information on our website. It's probably the best place to go first of all, so bentley.com. So there's a whole section on there on specifically energy production. So if you click on industries, you'll be able to go to the energy production section and read more about the subject. And I think also searching for Bentley Systems Energy, specifically on YouTube or LinkedIn, that will also uncover a wealth of other really useful background information. So yeah, those are probably the best sort of next steps to find out more in depth about these topics.
Now, what really stood out to me is the importance of understanding the full environmental context, again, above, on, and below the ground, when you're designing, constructing, and operating energy infrastructure. As Gavin explained, bringing together geospatial, geographical, geological, and asset management data digitally helps improve accuracy, reduce delays and costs, and minimizes ecological disruption. We also heard how IA is making a difference, helping create 3D models from photos, automatically detecting objects and geospatial data, identifying defects in existing assets. When all of this is connected through a digital thread within an infrastructure digital twin, everyone across the project can work with the same playbook, seeing the full picture and making more informed decisions. It's about turning isolated data in silos, into connected insight, and so thus delivering more resilient, energy efficient assets, built and operated in harmony with their environment. So a big thanks to Gavin for sharing how AI, geospatial intelligence, and the digital thread are helping teams, simplify complexity and improve outcomes right across the energy lifecycle. Now, if you'd like to learn more, feel free to reach out to any of us. Visit bentley.com or connect with Bentley Systems on LinkedIn or YouTube, where you'll find loads more information and more case studies. Thanks for watching. Till the next time.